Excuse me. Sorry. Yes, lesson, onto the lesson. Uh, right. Yeah. I was just, uh, I was just practicing, some, you know, I'm learning how to do image editing, and it's part of the school project. I just took as an example that, that. Whoops. Okay. Yes, now getting back to reality. Turns out that, well, you've probably done it yourself several times. I do it all the time, and all of us do all the time. Write down something which is not really, which in a sense, I should say, is not, how would you say, not good coding style. For instance, I write down all the time, and I'm sure you do too. Something like that, right? And then you go on with your program. Well, now, in a sense, syntactically, this is correct. There's no syntax error here, right? And there's nothing, doesn't seem to be anything particularly dangerous about that being there, right? And in fact, most of the times when I do, and all the times when I do this, I know that I'm doing this wrong thing, and the wrong thing that I'm doing is creating something called a dangler, if you want. It was mentioned at the beginning of Steve McGuire's book. He mentioned something called dangling ifs. And this here is a dangling if, which is allowed in C and not allowed in some other computer languages. For instance, Fortran has, for its if clauses, you have to make an if, I think maybe some capital, if, and then there's some condition, condition. And then there's no brackets or anything, then you just have statement 1, and the statements are lined up like that. I don't think there are any semicolons, and then end if, something like this. It all looks very square in Fortran. So an if has a beginning and an end, and you have to specify both. You aren't allowed to write this, which is what I just wrote, right? Now there's a reason why they do that, and there's a reason why, and for that same reason, this in C, even though it's allowed, is syntactically legal, but bad style because it introduces one of these dangling ifs. Now, I've known for ages that I have dangling ifs in my code, and I know exactly where they all are, and so I don't worry too much about it. And I'm always thinking, well, one day I'll fix it. I'll just go through and clean it up because they're mostly macros. And since now that some people have downloaded some of the code, I thought it's time that I clean it up and make sure that I don't leave any more of those dangling in. Now, what I've done is it took me, I don't know how long to create this sample, and it's probably not the best sample, but here's an example program I made. I can never get this right, but anyway, forget about the details. So just look at this code. Let's pretend let's pretend that this is a program, okay, and I can trace messages or not, maybe depending on its debug mode, right? And here it says if there are no arguments supplied, I'm going to trace a message that something bad happened, and I wanted to put here same thing. Oops. Right? Yeah, that's coming later. Okay, so now I supplied an argument, the program is running. Now if I don't supply an argument, run, it says needed 2 arguments, my turbo message. I had it all nicely comically set up, but I can't get the trues and the false to agree with each other. Anyway, now so far this looks okay, right? And if I go and turn off the tracing, shouldn't make any difference. Okay, something bad happened. The program certainly didn't run. And now I add an argument. And it's running. Everything's fine. I can have trace, I can have no trace. Now you might come along and say, well, geez, this kind of looks dumb. Why don't I just put else here, right? And I'll set this to true. Imagine I might have some initialization code in here. Extra initialization in the case where there's no error. Right. Okay. Now I can just test that flag, right? Instead of checking this. Why check that? Why check the same thing twice? Now I put curlies here because I'm imagining there might be several things maybe. So everything should be fine now. I've got an argument. The program should run. Oh wait a minute. It's only ever been false. This is supposed to set it to true. And try both cases again. Okay, now that didn't work, right? So this never got set to true. I didn't pass an argument, right? Well, we better put the tracing back on and see what's going on. Okay, going to the trace. Now, okay, so if I got the tracing on, it says it worked properly. Well, if I put an argument in, it's still going to work properly. Now what happened? Now I turn the tracing on. Now it would have been false, but B initted was false, so the program didn't run. So in neither case did the program run, and all I've done is turn the tracing on or off. But even worse would be if this was the other way around, I think. The default here was not, if this isn't initted, but not initted. That's true. Not initted. So this is the problem I get into. I'm trying to just create a situation where the behavior is correct, whether with the tracing on, but incorrect with the tracing off. And that's why I keep getting messed up. If not initted. Now maybe that should work. Because we're defaulting to initted, which is argument. I have an argument. I have a tracing. I don't know what to call it. But when this gets entered, I want it to return. Okay. So whatever the meaning of this flag is, okay. The point I'm trying to make here is that when you're looking at this code, it appears as though this belongs with this, right? But because of the way that this macro is defined, this else belongs with the if in this macro. See? So when this is false, when there's no tracing, then this part gets entered, right? Regardless of argc is actually useless, right? If I use argc down here, everything will be fine because I'm not relying on this case being entered. But the real problem is that this macro is incorrect. It has a dangling if. It has an incomplete if statement. There's no else part, right? But here's an else that gets picked up by it, and that's what a dangling if is. I've had these dangling ifs all over the place in this code. And I know about them, and I know where they are, and I'm wary of making a mistake, especially if other people are going to use the code. So I went around and I fixed up most of them. One of the ones is in a place where I use a special tray. And this was one which I've known about, of course, but I only used that macro in specific scenarios. And I know about it, and I know to be careful. But I shouldn't have to be careful. It's easy enough to fix. But here, let me just show you. It's well, several actually, but specifically to do with lists. Suppose I have a list of strings, I don't know, and what I'll do is I want to count from up to argc. RV and index. According to theory, that argc will be correct for this array. That is argc indicates that argc minus 1 is the highest available index in this array of strings, right? So there's nothing wrong with this loop, and now I have a add and I have a macro to simplify walking through a list and let's say printing them out. So I'm going to close down. Iterate list iterate. It's always been called this, and I'll use it. There's forwards and backwards, so if I put an F here, it'll at least tell me what I'm supposed to put in the type. The list name and the variable that I would like for the string element taken out of the list, called stir. Okay, one thing I can do is print them out. There's only going to be, depending on what I've got here, 2 things printed. Right? Okay. Now the problem is that this macro has always had a dangling, at least one dangling if. Now that's not too bad because people don't usually start to write else here, right? So it's not critical, but it could end up getting involved with an else, right? Somebody could say if something, just like I had before, go through this and you can put it on a single line and make it look like a single statement, which it is. It can be put on a line else, right? But that else is going to wind up, it's never going to get entered because the if that dangles from this TS list, that had dangled from that TS list, was a true value, so it was an if true, then print the strings out, right? So that would mean this would never get entered, and that's bad. That's why I've always those do this or put another bracket around it. But no longer do I have to do that. Fix it up. Now, you might laugh when I hover the mouse over the macro, what it looks like. But trust me, it's not as bad as it actually looks. Okay, this is the macro. All right. It makes me laugh when I look at it, but it makes perfect sense. The only reason it looks so terrible uh, is because it's repeatedly using one of the greatest tricks that I ever heard of, that I didn't invent, but just this thing, and they introduced those dangling imps in the first place. And the name for this trick, and I wish I could remember it. Hang on a second. Yes, sorry. Yeah, the trick of this and several other macros that I have used has a name. I don't know what it's called, but it could be called something like conditional in declaration in scope or something like that. And the way it works is like this. This is the idea. It turns out that you can declare and assign an object inside of an if clause, provided that whatever it is you declare can be tested. It's not a void expression. So, for instance, I can say if bool, usually it's like once, right, equals true. This is how I found out about this. I read someone some code. Someone had written something like this. A friend of mine, and told me that it's the greatest thing since sliced bread. And in a sense, it is, because it allows you to do things that you always wanted to do, but you just never thought of this. So it's kind of a silly trick. Okay, now this is just obviously going to be true, right? Now B once turns out down here is in that no B once doesn't exist here. It's only valid for the scope immediately following it. Oh, sorry. It doesn't exist here. It does now, but it won't in a minute. Now, so if that expression is true, which it is, I say for, now I can just do any kind of declaration I want. For instance, I might declare a string and give it any name I want. And I can assign it in any way I like. I could even do something that results in a void expression. Okay, we'll call it, actually, I can't take it out of that list, but I'll take it from RB. Alright. Now, what I want to do is I want to use this string once. Like I want this to. What I want to do is enter into a scope, use this declared string, and then be done with it. So I can do that. by making the condition for this for loop to be that Boolean I just declared, and then the action to perform at the end of each iteration of this loop to set this to false. Okay, so that means that curly brackets here, I can use stir. So neither, at this point, neither of those variables exist here. Okay, now what have I supplied here? argv. Well, maybe I could, if I wanted to turn this into a macro that gets me as a TS string the case argv, provided it's in range, I could just call this if get and r, and we'll take an index and a name for that string. And this will be the macro. We can put it on another line. Okay, and this will be an index, right? Now, but we got to make sure that we don't want to go out of range. So what I can do is I can let this be once, do it once if n index is less than or equal to, no, less than argc, right? So I can say if get and let's see, one string and print the string out. It's a useless macro, but whatever. It's pointing out the fact that I can declare a string, but I don't have to do it outside here. If I only need it in here, right? Should print it out. There it is. I don't have any leftovers variables. This should not compile. See? Normally, what you would have to do is you would have to declare a string, right? Well, you could check the argument and declare a string inside here, but then that's another declaration. And also, I don't even need these curly brackets. It's still the same. It's still this still works as it should, and it's still true that stir is only a part of that expression. See? So it's convenient for that sense, in that sense. But of even more convenience is to do with these lists. And what I just changed to do with it was, well, first, like this iterate. Let me show you something I can do. just like C sharp. Um, okay, I'm going to print it out. How about that? There's one statement, just like that one of your lambda calculus things. So here I'm walking through the list and converting all of the elements of that list to uppercase. Now let's see if that actually occurs. You think that, okay, maybe I can copy them, but I mean, how am I going to, how can I use this thing with dot, right, and have that refer to something in this list? That would mean that this would have to be a reference. That would mean that I'd have to be, copying a new reference into stir on every iteration. Impossible, right? To make it believable, but I'm not trying to fool around here and fool you. I'm going to do that the way, and then do an iteration the way that you would have to do it normally. You have to create some variables like globals, this scope, and then you say, then you declare. Here I could declare a reference, right? Being constant. List. And I can print it out. Like that. Now I'm going to tell you right now that the two strings are going to come out and be printed in uppercase. You see? And I, this is not a second go or anything at that. I knew that that was going to happen because what I've done is something I wanted to do for a long time, which is to not have to make copies of these things when I go through these iterations. There's also, now, this is the same as this, it turns out. Forward is the default. Now, since they're references, that means that I have to add another version of this that disallows this type of modification, and that's const. Now, this should fail to compile because I'm modifying a constant. See, the references returned in each iteration from this statement are constant references. So now that's just something I've always wanted. Okay, this in particular, and that I can do it again using the same name. Let's do that. Without all those extra variables, you can see it'll still compile. We'll still get the same result. This one can be const if I want. I'm not modifying the reference. And it works. And so now I have a useful tool for walking through a list and modifying all of the elements in a particular way. So this is like an apply list, right? And here's what I want to apply to each element of that list. Now, how is this accomplished? Well, that's accomplished by this crazy macro, which isn't that crazy, really. Now, it's using the B-once trick, but as back to that B-once trick. In order to declare a variable, right? The reason for this single step for loop, it has nothing to do with the loop part. It's just so that I can make a declaration within the same, in one statement, right? And have that object that's declared not have to fall inside of the curly braces, but just be declared during the conditional, right? So like the conditional declaration, which is something that you always want. You'll notice that you're going to want it, and you'll probably end up doing this. Now this has a dangling. This is a true, an if true something, right? But there's no matching else. So to fix that, all you do is change this to false. Put an empty expression for the false condition and make this the else. So now we've got if else, and our single step loop is now closed, and we have an if and an else and no dangle. Alright? So now this can be any sort of declaration. And what do I need to do and iterate? Now these variable names mix the line number with the word dummy, and I can optionally, if I want, add an index if I want. I don't need two things here, in fact, but I happen to use it. You could, I don't know why, but for some reason I thought I wanted to have the ability to put an index. This is a numeric value, and this is just a part of the name. And this number can be also becomes part of the name, but maybe you might increment it. So it could be of some use, I don't know. The main thing is that these things can be used on different lines over and over again, and you won't get the same name. So here's the first ones, B1s. So here's our B1s equals false, and so it's just a funny name. Part of it containing the word B1s and something else. The reason I did this instead of just B1s is somebody might actually, that's a name somebody might use. I don't want to, mess things up with someone. Okay, so now I'm inventing another variable, which is an int pointer, which is count as the number of items in the list. And the reason I need to get the count instead of doing while pause is because I have to use a for loop for these things. And a for loop does something, does its thing, the thing that it does, at the end of each time through, right? But I need to do something at the beginning, and on the last iteration, I have to make sure not to do something. So I got to know the count in order to know not to do get next of the pause when pause is going to be no. Okay, it's just the way for loops are, right? They do their plus thing at the end. So now this is just the same as this, right? B1 equals not B1. So I get the count stored in this variable, which is valid throughout the entire line. Now I say equals true. I could say equals not B1s, but that would be even more typing, so I said true. Now again here, see, this is where I find the index a bit easier. I'm doing another one because I need to declare something of type list position, right? So I need another variable, so I got to do another one of these things. And that's just this again, is to get rid of the dangling. Yeah. Now I get the head position of the list, and again, the condition for which the next single step for loop should be executed is not only on the basis of the B1's thing, right? That is always not, right? To do it backwards, whoops, this has to be not. This was false. So we need to go one time through. This is false, and then it becomes true if we'll only go one time through. So here's the standard condition. If it's false, okay, go ahead with the loop, then it becomes true, and then it doesn't do another. But in this case, this position value also has to be non-null. So here's a second condition. If the position is non-null, and my once variable is false, proceed. Otherwise, I'm done. Don't do anything. At the end of that loop, set the B1 to true, which kills the loop of a single loop. It's just a one-off loop in one iteration. Now since pause was not null, I know that I can declare a pointer with some name, which is the address of the element, the first element in this case, because I'm going to I did get head position. Right? The address of the first element in the list, right? And I know that I'm safe to do this because I've checked already that pause is not null. So I can get that pointer. Now this is the way I'm iterating through the list, by retrieving pointers. Okay, now the reason I'm using pointers rather than reference, I could call this a reference and don't take the address here, is because I think I want to test that pointer to see if it can know. No. Get max. I know this is not 0. That's for the first element. And then I'm counting down P1 again. Oh, I see. Because it's because of the fact that the for loop does its next thing, whatever that happens to be, at the end, right? And so the last thing that's going to be read, like it or not, is going to be is going to be invalid. Pause is going to become null. And pause will be null when the count is 0, it turns out. I know how many there are now. And I'm definitely now, of course, somebody could mess it up by adding or taking things away from the list during the iteration and having taken care of that possibility. So, I could probably add another condition here, a loop continuation condition, this and that pointer is not null, something like that. That would help to avoid that possibility. Anyway, that aside, that allows me to at least assign this thing the value null, and I want to be able to do that. Alright, now here we are going to the next phase. Now I want to convert that. Now you got to imagine, this is a loop, it is a loop, and for each time through that loop I'm getting a thing with this name, which is a pointer to an object. Now what I'd like to do is turn that pointer into a reference. So I need to declare another variable. In order to declare a variable, I have to do another one-off loop. This is not a one-off loop. This is a real counting loop. So one-off loop declaration, which is that weirdo thing. Now I can declare a reference to a type of thing called var. This is the one provided by the user, which is the dereference pointer. And it's a non-const reference to object of type whatever. And this is just a single one-off thing. So this one is just used for a declaration and nothing else. And so that's how that works. Using that trick several times over in order to declare a count and a pointer and then a reference to that thing, all in a single line. And you saw this. This is quite useful. This part had to be typed in once. But that's the end of that story, right? From now on, this is the type of thing I write. I can omit F if I'm going forward, right? Let's do that. Undo something here. So, although it's a great big mess, it's a mess that occurs that has been dealt with and for now and forever. From now forever. And there's no dangling if. That's the main thing. This should fail to compile. Previously, it would have compiled easily because I was always using if. Those ifs weren't closed. So the rule to learn the programming lesson, how many hours, is don't dangle your eggs. Make sure that they're always closed. So if you have I mean, it's a sort of a rule. Uh, if it's a macro, definitely in the case of definitely for macros, don't dangle. Don't dangle. That is, close your conditions. Close up all conditionals. And all that means is if you have an if, then there should be an else. Right? This is okay. Not okay. That's got a dangling. Yeah. Right. And don't forget that this sometimes people take else if to be a statement on its own, but it isn't. It's if else, that's fine, that's closed, but now you've opened it up again, and that's not okay. Eventually, you have to have an else to finish it off, and you got to put something underneath that else, right? It can't be empty. So you might have if condition, blah blah blah. Well, that would be bad, right? Now somebody types if, that's the same as if going here, right? It's subject to this else. You've got to close it. Whoops. Now it's closed off, and now this if is its own if. It has nothing to do with this. Of course, your macros in themselves, if you're writing macros, you have to make sure that they can be they can be used as a single expression like this, right? And not be, if there's more than one line, you have to somehow put some curly brackets around it. I use the do while false construct for that. But another way is to just use a if true and then empty expression, sorry, if false, else, and then put all your macro lines here. In fact, if you look at most of my macros, I have a special macro called enter do, and I don't even need it. I thought I needed it, but now I know I don't. I still have that here. Oops. Yeah. This is called like new enter do. If I really want to make it something do while false, do while false has the advantage, several advantages. You omit the final semicolon, that forces the user to place a semicolon at the end. The construct is do bracket and then line 1 and so on. And then while false. Okay, now that if you do that, you get a warning, compiler warning, and I've always got this here in front of it. And then turn that into a macro called enter do. See? Suppress warning and then say do. And all of my macros, almost all of them, use that do while false. Here. Enter do while false. Enter do while false. Now that enter do while false is an expression of type void. It has no type. If for something, especially for things like assertions or whatever, you don't want to have this winding up in an if statement, right? That ensures that, for instance, in the case of an assertion, if you use this construct, your assertion cannot be placed in a conditional, and therefore cannot be, no comparison can be made with it, and therefore it has no effect on the code, and that's what you want. The debug code should not affect the regular code. It's meant to monitor the code, not to alter its behavior. And this construct has that property. Now this also works, right? First, I don't want any dangling ifs, so I start out with a false. Now, the condition here, not dummy bar equals false, is a dummy bar, I think. And that I think should have the same effect. We start out at false, yeah. I'm not setting it to true or anything. No, I am. So this gotta have none. Yeah. Okay. So I've got that the condition has to be false because we don't want dangling yet. Now, I want to do that again. I want to have another false condition generated. Why do I need the second one? Why can't I just say else do here? I'm not sure. I don't see why I can't just do it. If dummy bar equals false, else do blah 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 while just dummy bar. I don't see why that wouldn't work. Why would I get a warning? Maybe I get a warning. It could be that I do this together to eliminate the warning because there's an assignment, right? You trick the compiler into thinking I'm doing something with this variable. Here, maybe it's smart enough to realize that this is set to false, and the comparison is, already determined. It could be. Anyway, so that's just a little tip for you, and I'll try and think of something next to do. Okay, see you.